So we want to find vertical asymptotes and removable discontinuities. Okay, that's a fairly easy task because what we are required to do in order to find that is to factor the numerator and factor the denominator, which most of us should be pretty expert, have mastered by this point. So this is going to be x minus 4 and x plus 2. That's factoring the numerator. And then x plus 2 and x plus 1. Notice that I can divide those terms out. And so what those actually produce is the value that makes them 0. So x equals -2, which is the same value over here. That's the value that's going to produce the removable discontinuity. Okay, which we'll see what that means in a graph here in a minute. The value that makes this one a 0, which is an x equals I've got a little lag here on my writing. X equals 1. That is going to make a vertical asymptote. Okay, so I'm just going to over here just write x squared minus 2x minus 8. I just need the equation because I'm going to go to the calculator. And unfortunately, this lag is slowing me down just a tiny bit. And I want us to remember the x minus 2 and the x minus 1. So minus 2 and minus 1. I'm going to put those there. I'm going to erase the rest just because it's going to get in the way when I look at the calculator. So I'm going to go to the calculator. And I'm going to put in the rational function, which is x squared minus 2x minus 8 divided by x squared plus 3x plus 2. And I'm going to go ahead and look at the graph. Okay. And what you're going to see is this. This value here is where we have the vertical asymptote. Maybe there's a better way for me to have drawn that. Let me see. If I draw a line and let's draw red. It's telling me it's at -2. No, I'm sorry. That is actually where the removable discontinuity is. The asymptote is at -1. So this is where the asymptote is. It's not going to let me write asymptote. Is at the -1. The -2 has a removable discontinuity, which is actually kind of like a hole in the curve. That's what a removable discontinuity is. So we found those two by factoring the rational function.